A structure is a data type in which each individual element has a name. It is opposed to arrays, where each element in an array is referred by a number or index. A structure is also a data type that can host heterogeneous data elements, which means those data elements can have different data types. This is very similar to cell array discussed before. However, the difference between a structure and a cell array is that a structure refers to its data element by name, while the cell array refers to its data element by an index. The individual elements of a structure are known as fields, so each field has field names. And for each field, it can be a different data type. For example, the first field, it can have a data type of a numerical vector, and the second field can have a data type of a string. So if you put the same structure together, and you can form a structure array. And in this structure array, each element have identical fields, and the data are stored in each field can differ. Here is an example of a structure. It has a name called student. It has 4 fields with field names as name, address, ID, and email. Among the 4 fields, the fields name, address, and email can be strings, and the field ID can be an integer. There are 2 ways to create a structure. The first method is to create a field of a structure through direct assignment. In this statement, we create a field of field 1 in a structure called str_array, and it is assigned with a value called val1. Similarly, you can create a second field. And if the field already exists, then it will assign the value, just basically update the value. Secondly, you can use a function called the struct to create a structure directly. And in this function call, you have to provide the field name as well as the value of that field as a pair. For example, here it will provide a field name called field1 with a value of val1, and the second field with a field name called field2 and the value of val2. And you can add as many fields as you want in this function call. Here is a list of structure functions. The first function is called field names, and it will take the variable of a structure as input and return a list of field names in a cell array of strings. And here is a very important point, is that the data you get back from this function call is a cell array of strings, not an array of strings. The reason is that when you look at the field names, you can hardly see that 2 field names are the same size. Therefore, the field names are usually in different sizes, and if you put them together, they cannot form a field string array. Instead, we can treat them separately as different data type and put them in a cell array. And this is also a use of cell array in MATLAB. The next function is called getField. It will take the field name as a string as the input and will get you the value of that field. rmField is to remove a field from a structure. And what it takes is the name of the field as a string as the input. setField is to assign new value to a field. So it will take two inputs. One is a field name as a string, and the other is a value. The last function is struct, and we have discussed it in the previous slide. Dynamic field name is a string enclosed in parentheses at the location where the field name is expected. There are actually two types of field names. One is called the static and the other is called the dynamic. And this is the static representation of field names. It starts with the structure name and follow with a dot and then the field name. And in this kind of expression, everything is fixed. There's nothing you can change to this expression. However, you can choose another type of field name expression. It's called dynamic field names. And in this place, you will see that the field name is replaced by a parenthesis, and inside the parenthesis, that is a string. And this string is the name of a field. And what is the benefit of this? Well, you can actually replace the string with a variable. And if you assign the variable with a string that represents different fields, then you can use the same expression to access different fields of a structure. So far, we discussed structure. As for structure array, it's relatively simple. You can put elements of the same structure together to form a structure array. In order to access a field in one of the structures, what you need to do is to access the structure in the array first using index, and then you use a dot name to access the field name. So in this example, what we did is to pick the first structure from the structure array stored in the variable called the student, and then to access its field called name. Here is a summary. So we discussed the sparse array. And basically, it's a special type of array that has most of the elements are zeros. And there's a special way to store the sparse array. That is, we store the non-zero elements with their index. Cell array is a type of data type that can hold heterogeneous data types. Each cell holds a specific type of data. And just keep in mind, cell array actually stores a pointer of those data in an array, and then use the pointer to access the corresponding data in other locations of memory. Structure is another type of data structure that can also host heterogeneous data types. It's different from the cell array in that it uses a field name instead of indexes to access those data.